Okay, so what we're going to do is take a look at the review for your test, which we'll have tomorrow. And the reason I want to go over this is to make sure that you have all of the correct answers. Yes, you may have answered them on your paper, which is great, which is what we want. But I want to make sure that you have the correct answers. And so that's what we're going to do. So that way you can take this home and use it to study for your test tomorrow. So first thing we're looking at is Newton's laws. So we're trying to say, okay, what is Newton's first law? Newton's first law. Newton's first law deals with, it's our key word, inertia. Inertia is this idea that objects have mass. Things that have mass have resistance to change in their motion. Okay, so Newton's first law deals with inertia. Inertia is mass. And so mass is really, if you think about it, resistance to change in motion. In other words, if an object is in motion, it wants to stay in motion. If it's at rest, then it wants to stay at rest. Right? The bigger, I should say, the more massive the object is, the more likely it's going to do what it's doing. Newton's second law deals with this idea that we have a force, you have mass, and you have acceleration. The relationship between force, mass, and acceleration. We can write it in an equation. This is where you would have some problems, some calculations to do, where if it says, what is the force? We multiply mass times acceleration. We have a triangle that we can use. And you use it in this actually, where F is on top, M, and A is in your lower right-hand corner. It's a little hard to read. Fine, you don't necessarily have to write that because we have that later on in the review. Newton's third law deals with action, reaction. They're pairs of forces, action, reaction, pairs. And so this is the one where we said for every action, there's an equal and opposite reaction. So your reaction is always going to be equal and opposite. Your reaction is always going to be equal and opposite. Okay. So, little reminder. If a baseball bat hits a ball, that's the action. What's the reaction? The ball hits the bat. Good. You remember. So now let's identify the following: first, second, or third. Well, if we go back up here, we can see that F equals ma. Well, where is that? Right here. That's A. So this is going to be second law. Inertia. We go up here and we look. Where's inertia? There it is, right there. So this is going to be our first law. Where do we have action-reaction pairs? We take a look, we find it, and it looks like it's Newton's third law. So we're going to put third right there. So those are some of the key words to look for when you're trying to identify which one of Newton's laws we have. Part 2, we're going to look at balanced and unbalanced forces. Circles balanced or unbalanced. Forces cause a change in motion. So if there's a change in motion, what is that? Unbalanced. Net force of 0, that means all the forces acting on it add up to be 0. Let me give you an example. If we had a box, we had 3 newtons in this direction, and we had 3 newtons in this direction. This is balanced. The net force would be 0 because if we have opposites, we would do 3 minus 3. That would end up with a net force of 0, and we know that that is balanced. That's why I wanted to draw that for you, because this may not have made sense, but if you have it drawn out, that made a little more sense. Force results from forces with equal magnitude, equal and opposite. So equal and opposite, balanced. Equal, these are equal in size, 3 and 3, and they're in opposite directions. That's what we mean by that. What is the net force? So here we're going to calculate the net force. If they are opposite, you subtract. So 400 minus 200 gives you 200. And what direction is it going? I'm going to go left. So you can just put an L for left, or you can write it out. It's fine. And we know that it's unbalanced. So we can just circle unbalanced.
We have to write that down too.
No, just circle it. 400 and 200, not balanced, right? So it's unbalanced. All right, we look at the next one here. What is the net force? Well, they're opposite. So we're going to subtract. 30 minus 25 is going to leave us with 5. It's going to go in the direction of the larger force. So 30 is over to the left. And we know that they're unbalanced because they're not the same. Are we good on this? Move right along. 6, 8, that means that we know that they're unbalanced. They're in opposite directions, so we're going to subtract. So 8 minus 6 is going to give us 2. And then it's going to go in the direction of the higher force. So the 8 is to the right. Okay, right. Next one. We look, we see that they're both 15. They're equal. They're opposite. That means they're balanced. Net force, if they are balanced, adds up to be 0. It's not moving left. It's not moving right. It's just 0. An object is pulled with a force of 20 newtons to the right. So I can draw it out. 20 newtons to the right, and with a force of 10 newtons to the left. Draw a diagram to show what's happening. We did that. Determine the net force in what direction. So they're opposite. I'm going to subtract. 20 minus 10 gives you 10 newtons, and the larger force is to the right. That's my answer. Let's circle that. If you didn't do it, go ahead and draw it in now. Now you know what to do. Next part, number 12, calculate the net force and direction. So these two arrows are in the same direction. So what are we going to do with these? We're going to take this and this, and we're going to add these two. And so that gives us a total of 12 in this direction and 15 in this direction. So these are opposite. You subtract and you get 3. Because that's the larger force, it's going to be to the right. Here we have an arrow here and an arrow here. These are in the same direction. So these two, we're going to add. So 5 plus 4 is 9. So if we get a total of 9 in this direction, but we have 9 going the opposite direction, I know the net force is 0. Which box shows balanced force? Box B does, because they're balanced. 9 in one direction, 9 in the other direction. Which box will accelerate? In other words, which will change its motion or move? That's box A, because those are unbalanced. Which best describes the relationship between force and acceleration? Between force and acceleration. So you can use your equation or just kind of think about it. Does more force produce more acceleration, or does more force produce less acceleration? If you push something harder, what's going to happen? It will move more. So more force means that it'll accelerate or move more. Okay, that's what we meant by that. All right. Which best describes the relationship between mass and acceleration? There you go. We don't need to know exactly how much mass, but if the thing is bigger and you pull with the same force, which one is going to be harder to pull? The one that's more massive or the one that's less massive? More massive. So more mass means less acceleration. What would be easier to pull in a wagon? A little mouse or an elephant? The mouse would, right? The mouse would be much easier to pull in a wagon, right? So that's what we mean by that. If it's bigger, it's going to produce less acceleration, less movement. All right, true or false? Inertia is when objects resist change in motion. That is true. A ball at rest has inertia. Is that true? Yes. Objects at rest want to remain at rest. A ball in motion has inertia. That is true. A ball in motion wants to remain in motion. Inertia can only be changed by a balanced force. No, because with a balanced force, what does a balanced force produce? No motion or no change in motion. So if they're balanced, there's no change in motion, which means the object is going to continue doing what it's doing. There's no change. So inertia can only be changed by a balanced force. That's false. It has to be an unbalanced force. Inertia means an object wants to keep doing what it is doing. That is true. A driver suddenly stops his car when he sees a dog run in the way. Why does he continue to move forward? Why does the driver keep going forward? Why does the safety belt have to keep him from moving forward? Because objects in motion will remain in motion, which is inertia. All right, if you have a bowling ball and a soccer ball, the bowling ball is 4.5 kilograms. The soccer ball is only 1 kilogram. If they're moving at the same velocity, which one has more inertia? Which one would be harder to change its motion? The bowling ball. The bowling ball. Student pushes blocks. This one you can't see, and I didn't realize that it blocked this out. But it said a student pushes the blocks and slides it across the surface. What stops them from moving or slows them down and stops moving forward? Because of what? Friction. Friction slows everything down and causes things to stop. Which one has more friction? A dirt road or an icy road? Dirt road, right? We saw what icy roads could do. You have the cars slipping and sliding everywhere. All right, last bit. F goes in the top, M goes in the lower left-hand corner, A goes in the lower right-hand corner. Oops, where are we at? So force is mass times acceleration. Mass is force divided by acceleration, and acceleration is force divided by mass. So the way that we're going to do these problems, we're going to underline our numbers. So this is like the guess method. We're just doing a little bit different. The G is the given, so underline. 10 kilograms is mass, so I'm going to put M for mass. 3 meters per second squared, it tells you it accelerates, so that's A. That's your given. The U is the unknown, so the unknown is what is it asking for. So I'm going to circle that. What force is needed? So now we can write the equation. We know we're saying force, so cover up the F. F equals M times A. Then we can substitute. F equals 10 times 3. And you get 30 newtons. All right, let's go to the next one. The G is the given. So I'm going to underline it. Tells you that it's acceleration. Tells you that that is the force. Circle what it's asking. It says, what is the mass? So I'm going to go up here to mass. I'm going to cover that up. And what are you left with? Force divided by acceleration. So let's write that in. Mass equals force divided by acceleration. The force is 14,000. The acceleration is 5. And so, ooh, that's a big number. What is that? Anybody divide that out? 280. Is it 280? I think it's 2,800 kilograms. So the answer here was 30. The answer here was 2,800 kilograms. All right. Underline our numbers, 50 newtons, 10 kilograms. This is force. This is mass. It says how much acceleration. So I'm going to circle what the question asks. Yeah, so go up here, cover up A, and so we're left with force over mass. Acceleration is force divided by mass. So it'd be 50 divided by 10, and that would be 5. Very good. 5 meters per second squared. All right. Underline 49 newtons, underline 7 meters per second squared. So it says this is force, this is acceleration. Find the mass. From our triangle, mass is force over acceleration. It'll be 49 divided by 7. What's 49 divided by 7? 7, yeah, good. 7 kilograms. Well, that's why we're going through this, so to show you how to solve for it. 20 kilogram, that's mass. Meters per second squared is acceleration. What is the force? Force equals mass times acceleration, right? Force, cover that up, is mass times acceleration. That's where we got this from. So then we're just going to do force equals 20 times 10, which gives you 200 newtons. I'll highlight that, make it really easy to see. If put, let's see, underline newtons, underline 0.5 meters per second squared. This is force. This is acceleration. This says what is the mass? Mass, cover up mass is force divided by acceleration. Use your triangle. It'll tell you what your equation is. And you don't have to guess whether you're multiplying or dividing or anything. What does it ask for? It asks for mass. Okay, cover up mass. What am I left with? F over A, which is dividing. So force over acceleration. 40 over, hopefully you do now. 40 divided by 1/2 is 80. 80. You were looking for 80. 80 was the right answer. 80. And that should